Hi folks, Dr. P here. In this video, I will be showing the video solution for linear scale factors 4. Vasa is a Swedish warship built between 1626 and 1628. The ship tipped over and sank after sailing only about 1 kilometer into her maiden voyage. After her sinking, she fell into obscurity for over 300 years until she was located again in the late 1950s in a busy shipping lane just outside of Stockholm Harbor. The ship was salvaged with a largely intact hull in 1961. The ship is now located in a museum and is one of Sweden's most popular tourist attractions. Using the information in the image of the model kit, determine the actual dimensions, length and height of Vasa. Provide dimensions to the nearest hundredth of a meter. We have a hint here. If we click on that, it tells us that 1 kilometer equals 1,000 meters and 1 meter equals 100 centimeters. And there will be a conversion we'll have to do here. If we take a look at this picture here, this is a picture of the box for a model kit for this ship. There is an enlarged version of it down here containing the information that we need. And if we see different color, if we take a look at the information on this label, it tells us the linear scale factor. So this is the linear scale factor of this model, 1 to 150. And down here, it tells us the size of the model ship. So once it's built, it's 45.5 centimeters long, and it's 34.5 centimeters tall. And we want to use this information to determine the actual dimensions of the real-life Vasa. Okay, so we're going to be using the linear scale factor formula here. The linear scale factor equals the new dimension divided by the old dimension. In this context here, the new dimension is going to be the model, the dimension of the model, the length or the height of the model. And the old dimension is going to be the actual size, actual length or actual height. So now we can go ahead and we can determine, we're going to have to do two calculations here. We have to determine the actual length of the ship. So we can plug in information that we have. We know that the linear scale factor is 1 to 150. We know that the model is 45.5 centimeters long. And then we're trying to determine the length of the ship. So I'm just going to call that L in the denominator. So we want to solve this for the length of the actual ship. So what we can start by doing here, we can take the reciprocal of both sides. What that will allow us to do is it'll allow us to move this variable into the numerator. Right now it's in the denominator, the length is in the denominator, which is a bit of a problem. So we can simply take the reciprocal of left and right hand side, which is we just flip those quotients upside down on both sides. So it's going to end up looking like this. When we're solving for an unknown variable, you can really do anything you want as long as you do the same thing on the left and right hand side. So if we do the reciprocal on the right hand side to get the L upstairs in the numerator, we have to do the same thing on the left hand side. Now all that we have to do is multiply both sides by 45.5. So it's going to be 150 divided by 1 times 45.5, and that's going to give us a length of 6,825 centimeters. Now they want the answer to the nearest hundredth of a meter. So we need to convert this from centimeters to meters, and we're going to do that by dividing the centimeters by 100, because 1 meter equals to 100 centimeters. That's what it told us in that hint. We divide those two numbers, and we're going to get 68.25 meters. So the original ship was 68.25 meters long. Now we have to do the same calculation for the height of the ship. So exactly the same. The scale factor is still 1/150. The height of the model is 34.5 centimeters. And now we're looking for the height of the actual ship. We're going to call that h. Take the reciprocal of both sides. Multiply both sides by 34.5. And that's going to give us a height of 5,875. Let me just check that calculation. I got it right. 150 times 34.5. Sorry, that was wrong. 5,175. I thought it sounded off. 5,175. So that's centimeters. To convert this to meters, it's going to be 5,175 divided by 100. It's going to give us 51.75 meters high. That's a wrap. Until next time, may the math be with you.